Good day, M2. This is Teacher Win, and welcome to Work and Power. So for this video, we are going to talk about work and power. So for more information, so you can read your book on pages 55 to 58. So let's begin first with work. The term work in science is different from the usual way we understand it. So like for example, I am working hard to understand my English subject or my science subject, or the sentence he is working part-time, or he is working at home, or he is doing his homework. So those statements or those sentences, they do not help in explaining the scientific meaning of work. So how do we define work scientifically? So in science, you can say that the work is done if number one, there must be a force applied on an object. So meaning, if you are using the force, so you're going to focus the force on that object. So it can be like pushing the object or pulling the object. Number two, the object must move. So therefore, if the object is not moving, so there is no work done. And number three, the effective part of the force is in direction of the movement. So if the pushing force is going to the right, then the object should move also to the right. So if the object or the force of the object is moving up, then therefore the force also or the object should move upwards. So I have here different examples on how do we define work. So we are going to use this criteria to determine if there is work done in each activity. So number one, a rock moving at constant speed in outer space. So that means, so this rock that you can see in the picture, so you imagine this rock is in outer space and it's moving constantly. So let's try to check if all of the criterias are checked. So for number one, so there must be a force applied on an object. So since the object is not changing the speed, so therefore there was no force that is being applied to it. So therefore this is an X. So the object must move. So moving at a constant speed, so it will tell us that the object is really moving. And the effective part of the force is in direction of the movement. So the object is moving, however, there's no force applied. So therefore, this one is wrong. So therefore, the question is there work done? So the answer is no. So this is what I mean, M2, that the word work in science is different. If we talk about in normal ways, in ordinary means, so since the rock is moving, so there should be work, right? However, in science, since there are two criterias that are not met, so therefore, this object is not doing any work at all. Okay, number two, a child pushing against a big rock, but it does not move. Is there work done? Okay, so let's try to check. So number one, there must be a force applied on an object. So as we can see, the child is pushing the rock, so meaning the force is being applied to the rock. So therefore, this one is checked. The object must move. So even if the child is pushing the rock, but the rock is not moving, so therefore it is an X. So the effective part of the force is in the direction of the movement. Yes, the force is there, but the object is not moving, so therefore this one is an X. So is there work done? So the answer is no. So M2, so for you to consider that the work has done, so the three criteria must be checked. If there is one X, so that means there is no work done. Okay, this is my last example, number three. The basket is carried along at constant height above the ground. Is there work done? So our focus here is your basket. So let's try to check if the basket has meet the criteria. So there must be a force applied on an object. So basically, so your basket is already above the ground. So that means there is no force applied. Where is the force applied? The force applied is here in your feet. That's why instead in your basket, so the force is directed to your feet so that you can walk or move. Number two, the object must move. So there is an object moving in this picture. However, for number three, the effective part of the force is in direction of the movement. So your force applied is into your feet, right? However, that force is going down. However, your basket is moving to the right. So meaning, so there is movement, but however, the force is in opposite direction. So therefore, this one is an X. So is there work done? So the answer is no. Okay. Now, how do we compute the amount of work that you have done or an object that has done? So in this picture, so it shows a force, which is your letter F, okay, and then pulling a block of wood over a distance. So this one is distance. So shall we say, if this mark here is your 0 meters, okay, and then if you pull the object to the right, so that means this object, shall we say this point is 1 meter. So that means in this picture, so shall we say you applied 1 Newton, okay na? You applied 1 Newton in order to move the object for 1 meter. Okay, so let me just write this one. So imagine you applied 1 Newton of force in order to move that object for 1 meter. So in the unit of work, we are using the unit joule, or abbreviated as letter G. So your joule means that the amount of work done when a force of 1 Newton moves an object by 1 meter in direction of the force. So as you pull the object to the right, the object is moving also to the right. So if I use 1 Newton of force to pull the object, then the object is also moving 1 meter to the right, the same direction as my applied force. Okay, so let's try to do these activities or examples in relation to your work. Okay, so let me just read number 1. A man pulls a box along the floor. The distance moved is 40 meters and the friction is 150 newtons. So calculate the work done. So if we go back to the example, so this is your situation looks like. So here is a box, and then here is like the floor. Okay, so the distance that your box has moved is 40 meters. Okay, and then the friction is 150 newtons. So the opposite force is 150 newtons. Now, for you to move the object, your force should be at least more than 150 newtons. So therefore, if we are going to identify our given formulas or our given values, so we have here your work done, which is we don't know yet, so let it be as your x, and then we have here your force. So the amount of force that we are applying is 150 newtons, and then the distance. So the distance is how much? That is 40 meters. So our formula here, so our formula that will be work is equals to force multiplied by distance. So our solution that would be, so work done is equals to your force, which is 150 newtons, multiplied by 40. So I'll just remove the unit. So that will be x, or work done. That's 150 multiplied by 40. So that will be 6,000 Newton meter, or you can just say 6,000 joules, or you can just say 6 kilojoules, because K here means kilo and kilo is 1,000. So 1,000 times 6, that's 6,000. Okay, number 2, a man tries very hard to lift some weights using a force of 500 Newton. However, he cannot do it. So how much work has he done? So let's try to draw this one. So you have here like a person, okay, and this is like the floor, and shall we say this is like the weights that he is trying to lift. So he is using 500 newtons. However, the object or the weight is not moving at all. So let's try to identify first our given value. So our given here is work done, and we don't know yet. So how about the force? So the force here is we have 500 Newton. And how about the distance? So for the distance, so he cannot do it, so meaning the object is not moving at all. So meaning this is 0 meters. So our formula, so that will be work done is equals to force multiplied by your distance. So our solution, so that will be work is equals to force times distance. So let's substitute W with X, and then force, which is your 500, and the distance, which is 0. So therefore, so 500 multiplied by 0, so that will be 0 joules. So that means, so even if the person is using a force of 500 Newton, remember the second criteria, and it states that the object must move, right? So even if you applied force and the object is not moving, so therefore there is no work done. So this one, so let me just write it. So your 0 joules here, that means no work done. Now number 3, this is my last example. A girl carries a 4-kilogram school bag as she walks along a path of 20 meters long. How much work has she done to carry the bag? So if this is the girl, and the girl has a school bag which weighs 4 kilograms, and the girl is walking 20 meters long, so how much work has she done? So given here, so work done, which is an X. How about the force? Okay, so we don't have the Newton here, right? We only have 4 kilograms and 20 meters. So how do we get the value of force? So do you still remember our lesson about force, wherein your force can be acquired by multiplying your mass multiplied by gravity, right? So we're in your mass here. So your mass here, I'll just remove the unit now. So your mass, which is your 4 kilograms, and then the force of gravity, which is 10 meters per second squared. So that will be, so our force here, so 4 times 10, so you will get a value of 40 N. So this is our value of your force. So force here is 40 N. However, if you look at now the distance, yes, the object is moving, right? However, the applied force is not into the bag, right? The applied force is into your legs so that you can move. So therefore, the distance here is your 0. So that will be 0 meters. So our formula here, so that will be work is equals to force multiplied by distance. So our solution here, so that will be work is equals to force multiplied by distance. Force 40 and distance is 0, so that will be 0 joules. So this will be our answer here. So how much work? So it's the answer is 0 joules, or no work done at all. The next one is power. So power means how fast a machine, a thing, a person can do work. So you just imagine or remember the word how fast. So like for example, if you can do your homework very quickly, so shall we say you can do your homework for 10 minutes. So meaning you have a brain power that is very strong because you can finish the homework for only 10 minutes. So in order for you to know how much power did you use in order to finish the activity or an event very quickly, so we have here the power formula. So if you are using a machine, so you can use this formula. Power is equals to work done over time taken. Or in power here, it is expressed in the unit of watts. Okay, so power is expressed in the unit of watts. And then your work done here, so it is expressed in the unit of joules. Or energy used up, it is expressed also in joules. Time taken here, it is expressed in seconds. This one is expressed also in seconds. So let me just complete it. And this one is your joule here, and then here is your joule. So what does your watt mean? So your watt means that when 1 joule of work is done in 1 second by a machine or a device, then it is operating at 1 watt. Okay, so if your object, or if you're using a machine and then you finish in 1 second, so that 1 joule of work, which is good for 1 second, so you are using the machine with a power of 1 watt. So I only have one word problem for your power. So this one is a combination actually of your work and your power. So number one, a lift can carry a bag from the ground up to the 9th floor, which is 30 meters high in 1 minute. So question number one, if the bag weighs 8 kilograms, calculate the power needed to carry the bag up. And question number two, compare the power used by a boy who carries the same bag by walking upstairs to the 9th floor in 10 minutes. Okay, so let's deal first with problem A. So if the bag weighs 8 kilograms, calculate the power needed to carry the bag up. So we are asked to compute the power, right? So the formula of your power is equals to work done over time, right? So we have to know that for work, we need Newton, right? We need the power of joules, right? And to get the power of joules, so you need your Newton and then your meter. So therefore, we are going to compute first the formula for work done. So we have here your work done is equals to force multiplied by your distance. Okay, so there will be two formulas that we're going to use. Actually, it's three, because if you look at the problem, we don't have any newtons there, right? So we're going to compute for force multiply by your mass and your gravity. So let's begin first with your the first one. So let's begin first with your force. So our force here is mass times gravity. So what is the mass of the bag? Okay, the mass of the bag is 8 grams, right? 8 kilograms. And then the gravity, shall we say it's 9.8, but let's make it 10 for easy computation. So that will be force is equals to 80 newtons. So this will be our value of your force. Now, if you look at the problem again, the height of the building is 30 minutes. So meaning you are carrying the bag up to 30 meters high in 1 minute. So therefore, so using the problem here, so we can now compute your work, right? Because we already have the distance. So we're in. So here is our another solution. So work is equals to force times your distance. So our force here is 80, right? We got it here. And then multiply by the distance, which is your 30 meters. So that will be work is equals to 80 times 30. You will get 2,400 meters at 2,400. What's the unit? Okay, joules. Very good. So remember that work, we express it with a unit joules. So we already have now the force. We already have the work. And how about our time? So our time here is 1 minute. And your 1 minute should be expressed in seconds. So 1 minute is how much in seconds? So that will be 60 seconds. So therefore, to compute your power, so we have your work divided by your time. We're in our power here. So we already have let power bx, and then work here, which is your 2,400. I will remove the unit na, and then the time, which is your 60. So 2,400 divided by 60. Okay, very good. So you will get a value of 4t, 40. And what is the unit? What is the unit for this problem? So it should be in watts. So if the bag weighs 8 kilograms, so calculate the power. So the power that we need to bring the 8 kilograms bag up to 30 minutes is 40 watts. Okay, problem B. So compare the power used by a boy who carries the same bag by walking upstairs to the 9th floor in 10 minutes. So for this problem, you are now walking upstairs. So instead of riding your lift, so you are walking upstairs for to the 9th floor. 9th floor is still 30 meters. However, the change in time is now 10 minutes. Since problem B has a connection with problem A, so we will use the same force because we are using the same bag, right? So our given here, so the force applied in the previous problem, your problem A, so the identified force was 80 newtons, right? And also, since we are still carrying the same bag, 8 kilograms going to the 9th floor, which is 30 minutes. So work is equals to force times distance. So we will still have the same value of your work, which is your, how much? 2,400 joules. Okay? So how did I get again 2,400 joules? So I got it when I multiply 80 newtons multiplied by 30 meters, and you will get an answer of 2,400 joules. So we will be using this work. However, for the power, we don't know yet the given, or we don't know yet the answer. So for our formula here, so we are going to use power is equals to work divided by time. So our solution here, so we have here your power is equals to work divided by time. Your work here is 2,400 joules divided by time. This time your time taken is 10 minutes. So 10 minutes multiply to 60 seconds. So you will get 600 seconds. So 2,400 divided by 600. So you will get a value of power, which is 4 watts. So this is the answer for question B. So this is the end of the lesson for this video M2. So if you need more information about work and power, so you can read your book. And once you're ready, please answer pages 59 to 60 of your science book. And once you're done, so please upload it in the Google Classroom. So once again, thank you very much for watching and have a nice day, M2.